Hello everyone. Once again welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to troubleshoot one ticket of BGP. As you can see, scenario is very simple. We have only three router 1, 2, 3. All routers are directly connected with each other, and we are running BGP 65000. BGP AS number 65000 on all routers. You can see problem is here. Problem is after configuring BGP ES65000 on router 1, router 2 and router 3, user in 192.168.10.0/24 are not able to communicate with user in 192.168.20.0/24 network. So we have two LAN. Here you can see this is 192.168.10.0/24 and another LAN is 192.168.20.0/24. Engineer have configured BGP on these three router BGP 65000, but at the end these users are not able to communicate with this user, and as a network engineer you need to troubleshoot the scenario. So how we will troubleshoot it? What will be the what a step we will follow? So see guys, first of all we should verify the problem that really user in this network is not able to communicate with users in this network. So here I have console of all devices here in secure CRT: router 1, router 2, router 3, router PC1, PC2, PC3 and PC4. First of all, we should verify the IP configuration on PC and connectivity till default gateway. So let me take you to PC number 1, and here I am going to check IP. So IP all. So here you can see IP address is 192.168.10.1/24 and gateway is 192.168.10.254. Let me verify this is the IP address of router interface or not. Means router fast Ethernet 1/0 is connected with LAN interface. So this IP address should be the IP address of fast Ethernet 1/0 of router 1. So on router number 1, so IP interface brief exclude unassign. So correct, here you can see on fast Ethernet 1/0 IP address is 192.168.10.254. Last IP address of subnet is a gateway IP address, and that is correct on PC number 1. And on PC number 2, so IP all. On PC number 2, IP address 192.168.10.2/24 and gateway is, you can see, same 192.168.10.254. correct. Let me verify the IP on PC number 3. So IP all. Here also IP is 192.168.20.1/24 and gateway is again last IP address of this subnet. So let me verify this gateway also. Let me check the IP address on R3 interface. So IP interface fast interface brief, and we can say exclude unassigned. So here you can see IP address on fast Ethernet 1/0 is 192.168.20.254. correct. So PC3 have also correct IP address, and PC4 so IP all. PC4 have also correct IP address, you can see here. Fine. Now from PC1 I am going to ping the gateway IP address first. Ping 192.168.10.254. Yes, I am able to ping my gateway. Now let me ping PC3, the user in 20.0 network. 192.168.20.0 network. 192.168.20.1 is the IP address of PC3. Let me ping. Yes, you can see problem with we have some problem here. Destination host unreachable, right? This destination is unreachable. I am getting reply from my default gateway. Fine. I am not able to ping PC3. Let me check one thing. From PC number 3, I am going to ping the default gateway. Ping 192.168.20.254. Yes, PC3 is also able to ping their gateway. Now we should verify the routing table of all routers, like because both PCs in 192.168.10.0/24 networks are able to ping their gateway, and all PC in 192.168.20.0/24 networks are able to ping their gateway, but they are not able to communicate with each other. So let me verify the routing table. First of all, let me take you to R1. On R1, let me check. So IP route. In the routing table of router number 1, there should be one network like 192.168.20.0/24, but we are not able to see 192.168.20.0 network in the routing table of router 1. So we have problem here. Let me check BGP table. So IP BGP. In BGP table also you can see we don't have 192.168.20.0/24 on router number 1. Let me take you to router number 3 directly, and on router number 3 also first I should verify the routing table. So IP route, and in the routing table of R3 there should be 192.168.10.0 network, but here you can see we don't have 192.168.10.0 network in the routing table of router 3. Okay, let me check BGP table. So IP BGP, inside the BGP table also you can see there is only one network, and next of is 0.0.0.0 means self-advertised network. In the BGP table of R3 and R1 there is only one network, that is self-advertised network. Now I should check routing table or BGP table of router number 2 to identify that router 1 and router 2 is advertising self-advertised prefix to router number 2 or not, to their neighbor or not, right? Or what we can do, before verifying that, we can verify the BGP neighbor, like on router number 1. So IP BGP summary, I can run this command to identify the BGP neighbor. So yes, we have one neighbor 12.1.1.2. Guys, between router 1 and router 2 I am running 12.1.1.0 network, and between router 2 and router 3 we are running 23.1.1.0/24 network. Okay, so this is IP address of router 2. So neighbor 12.1.1.1, and state is, you can see, up, everything is working fine, we don't have any problem with neighborship. Then on router number 2 or on router number 3 also we can verify the BGP neighborship. So IP BGP summary. So here also router 3 have one neighbor, that is 23.1.1.2. this is IP address of router 2. So this neighbor is also fine, here we don't have any problem. Let me take you to R2 now directly. On R2 what we are going to do, on R2 directly we are going to check. So IP BGP summary first. So okay, both neighbor are there, fine. Then BGP table. So IP BGP. So in BGP table of router 2 we are able to see both prefix, like 192.168.10.0 also, and who is advertising 12.1.1.1 means router number 1. Next of IP address is the IP address of router 1, and this network 192.168.20.0/24 and reachable via 23.1.1.3 means via router number 3. So till here we don't have any problem. On router number 2, router 2 is receiving both prefixes, right? There is these prefixes are there in BGP table, and it will install these prefixes in the routing table also. If you will check routing table of R2, so IP route, let's say BGP, so you can see this router have installed these two prefixes in their routing table also. But I think problem is, as you know, here router 2 should be the route reflector, because both R2 have two neighbor and both are IBGP neighbor, right? So when router 2 will receive prefix from router number 1, it will not advertise to router number 3. In the same way, when router 2 will receive prefix from router number 3, it will not advertise to router number 1. This is IBGP loop avoidance rule. So here R2 should be the route reflector, right? Then only R2 will advertise the receive prefix from their IBGP neighbor to other IBGP neighbor. So what we can do here, we can configure the route reflector, and before that we should verify that engineer have really not configured route reflector here. So let me verify that. So run, let me check the BGP configuration. So run section BGP. So yes, here we don't have, on router number 2 we don't have route reflector configuration, so this is problem. So on router number 2 I am going to configure route reflector, router BGP 65000, and I am going to say neighbor, let's say 12.1.1.1 route reflector client, route reflector client. Or if you want, you can configure the other neighbor also, like neighbor 23.1.1.3 route reflector client. And now let me verify the BGP table of router number 1, router 1 BGP table. So IP BGP, Yeah, now you can see router 1 have received 192.168.20.0 network, but this network is not best only valid for now because next hop address is not reachable. And on router number 3 also, let me verify the BGP table once again. So IP BGP, here also R3 now have installed or received this prefix 192.168.10.0/24, and next hop is 12.1.1.1, which is not reachable from here. That's why this network is not best only valid. Okay, because as you know, this is also rule of IBGP, that whenever you will receive a prefix to your IBGP neighbor, and when you will advertise same prefix to your other IBGP neighbor, you will not modify the next hop. Means whenever you are advertising a prefix received whenever you are advertising a prefix received from IBGP to other IBGP, do not update next hop IP address. So what we can do here, like from router number 3, 12.1.1.1 is not reachable, so we can configure one static route for 12.1.1.1, or you can configure, you know, we can advertise 12 network in BGP also, that is also one option. Or we can use route map also, like we can configure the route map, and through route map we can add the next hop IP address, we can modify the next hop IP address. But for now, what I am going to do, see, first of all, understand guys what is the problem here. Problem is very simple. This prefix is 192.168.20.0. This prefix is connected with router number 3. Router 3 is advertising this prefix to router number 2 with this next hop 23.1.1.3, and when router 2 is advertising it to router number 1, router 2 is not modifying the next hop address, and this next hop IP address 23.1.1.3 is not reachable from router number 1. So this is problem. So we have multiple option, we have multiple way of configuration here to resolve this problem. But what I am going to do, I am going to advertise 23.1.1.0 network in BGP and 12 network also in BGP, right? So when I will advertise 12 network, what will happen? See, when I will advertise 12 network in BGP, router 1 will advertise 12 network to router number 2, and router 2 will advertise 12 network to router number 3, right? But if I will advertise 12 network on router number 2, what will happen? Router 2 will advertise it to router number 3. So next hop will be the 23.1.1.2 IP address of this interface. So we should advertise 12 network and 23 network in BGP on router number 2. So let me take you to R2, and here I am going to say router BGP 65,000, and then network 12.1.1.0 mask 255.255.255.0. After running this command on router number 3, if you will verify BGP table again, now you can see in the BGP table 12 network is also there, and for 12 network next hop is 23.1.1.2, right? And now 12 network is reachable, because of that this prefix also became best prefix. In the same way, on router number 2 we need to advertise 23 network 23.1.1.0 and say mask is 255.255.255.0. Now let me check R1 BGP table. So IP IP BGP. Now in the BGP table of R1 you can see 12 network is there, correct? 23 network is there, and because 23 network is there, this network should be the best. 23.1.1.0 network is there. Soon this prefix will become best over here also. Let me, yes, now you can see this prefix is best as well as valid. And now router 1 should install this prefix in their routing table. So IP route, let's say BGP. So inside the BGP routing table you can see this prefix 192.168.20.0/24, which is reachable via 23.1.1.3, and 23 network is also there. In the same way, let me take you to R3 now, and on R3 so IP route BGP. Inside the routing table of R1 also we are able to see now this prefix and this prefix. And let me verify the connectivity now. Let me verify the connectivity now from from PC number 1 ping 192.168.20.1. Now you can see ping is working. Now ping is working from PC number 1. I am able to ping PC number 3. From PC number 2 also we can check. Let me ping PC number 4 here, 192.168.20.20.2. PC2 is also able to ping PC3. Okay, that's great. This was the first troubleshooting. Like here, problem was with route reflector configuration on router number 2. Now guys, we are going to discuss trouble ticket 2. Again, problem is same. Users in this network is not able to communicate with user in this network. First of all, again I am going to show you the problem. See here, 192.168.20.1. See, destination host unreachable. Again same problem, right? On I am able to ping gateway 192.168.10.254. Yes, I am able to ping the gateway, but I am not able to ping the outside user, right? The users in this network 192.168.20.0/24 network. Again, we will verify everything step by step from the router number 1. First of all, we will check BGP table. Then we will check, first we should check routing table. So IP route. Inside the routing table, this time you can see inside the routing table of router 1, we have this network 23.1.1.0 through BGP and 192.168. This is directly connected network. 20 network 192.168.20.0 network is not there in the routing table of router 1, right? This time, and in BGP table, so IP BGP inside the BGP table also, right? So what is the problem this time? Now on router number 2 also we should check the routing table and BGP table. So IP route. So inside the routing table of router 2, you can see router 2 don't have 192.168.10.0 network or 192.168.20.0 network. So what is happening? Router 1 is advertising the prefixes to router number 2 or not, or router 3 is advertising this prefix to router number 2 or not, because this time this is not problem of route reflector, because here you can see problem is like something like router 1 and router 3 is not advertising prefixes to router number 2, because router 2 this time router 2 also don't have networks. Okay, so on router number 3 also we can check BGP table, and on router number 2 you should verify BGP table also. So IP BGP. So inside the BGP table of router 2 we have prefix. This time inside the BGP table of router 2 we have both prefix 192.168.10.0, 192.168.20.0, but these prefixes are not best, only valid, but next hop is reachable. Like from here, if you will ping next hop 12.1.1.12.1.1, you can see, and this next hop also 23.1.1.3, 23.1.1.3, both next hop is reachable, but still these two prefixes are valid, not best in the BGP table on router number 2. Now what can be the problem, guys? This time this is problem of misconfiguration, or like this problem look like on router number 3 also you can see. So IP BGP, this is BGP table of router 3. On router 3 BGP table we have only this network, so means router 3 have this prefix in BGP table, like a self-advertised prefix. Router 1 is also advertising prefix, but router 2 is not getting the prefix. So what we can do here we can check one thing. We can run command show IP protocol to verify the BGP configuration, or directly we can check the command which engineer have enabled here, because we know here we have very less number of route 3 routers are there, right? And we are running BGP 65,000 on all router, but there is some problem because of that router 1 and router 3 is not advertising, or it is advertising the prefixes but router 2 is not getting it. So from router number 1, let me check the configuration. So run section BGP. I am going to run this command. So run section BGP, and here you can see engineer have run how many command: router BGP 65,000, then BGP log neighbor change, okay, and this is by default command, then network command 192.168.10.0/24, and neighbor 12.1.1.2 remote AS 65,000, and neighbor table is also fine. So IP BGP summary, you should verify neighbor table as well of router number 1. You can see neighbor is 12.1.1.2, and on router number 2 also. So because we have neighborship only, that's why router 2 is receiving these two prefix in BGP table, right? So IP BGP summary, by the way, we can verify the neighbor table as well on router number 3 also. So IP BGP summary, neighbor table is fine, right? Now on router number 1, you can see guys how many commands we run in BGP, in router BGP, and each command is fine, and these are the only required command on router number 1, right? Neighbor 12.1.1.2 remote AS 65,000. So on router number 1 configuration is fine. Let me check the configuration of router number 2. So run and say section BGP or router BGP. Here we have run router BGP. We have some commands like router BGP 65,000, that is correct. Then synchronization is enabled on router number 2. You know what is the synchronization? Synchronization rule tells that do not use or advertise the receive prefix from your iBGP neighbor to your other eBGP neighbor, and don't use the prefix and as well as advertise to your other iBGP neighbor or to other eBGP neighbor receive from your iBGP neighbor. Means if router 2 will receive any prefix from their iBGP neighbor, it will not use that route, that network, that prefix like it is doing. So IP BGP, inside the BGP table, router 2 is receiving one prefix from their iBGP neighbor, that is 192.168.10.0, but it will not use it and it will not advertise it to your next neighbor. This is synchronization rule. Because of synchronization rule only, router 2 is not using this prefix. So synchronization rule is very simple. Do not use and advertise the receive prefixes from your iBGP neighbor to other BGP neighbor until and unless that route, means same route, is available in your routing table with iBGP. If you have same network, this network through IGP protocol, then you will use it, you will advertise it to your neighbor. But if you have no any route available from iBGP for this network, for this prefix, then you will not use it. You cannot use it and you cannot advertise it to your neighbor. This is synchronization rule. So what I can do, between router 1 and router 2, I can configure one iBGP so that router 2 will receive same prefix from iBGP neighbor. So it will start using this prefix and it will start advertising it to their neighbor. Second option is we can disable the synchronization rule here. By the way, before doing it, let me check the rest configuration. This is one problem. Synchronization rule is enabled here, and BGP log message log neighbor change, that is fine. Neighbor 12.1.1. network 12.1.1.0 mask is 255.255, that is fine. Network 23 network, that is also fine. Neighbor 12.1.1.1 remote AS 65,000, this neighbor route reflector client. Neighbor 23.1.1.3 route reflector client. Rest configuration is correct, and these all are required command on router number 2. As you know, we need to configure router reflector in the previous troubleshooting. Now here we have only this problem, synchronization problem. So what I am going to do, let me configure one IGP protocol between router 1 and router 2. So IGP means router, let's say OSPF process 1, and the network 12.1.1.2 0.0.0 area 0. This command will enable OSPF on fast Ethernet 0/0. Then router number 1, config T, router OSPF, let's say process 1, and network 12.1.1.1 0.0.0 area 0, and one more network 192.168.10.0. wildcard mask 0.0.255 area 0. Now what will happen, see on router number 2, now same prefix router 2 is receiving through IBGP also, so IP route OSPF. So through OSPF it have not received any prefix till now, so IP OSPF neighbor. So neighbor is in X start state. For faster convergence, we can change network type, like on fast Ethernet 0/0 IP OSPF network point to point. We should configure this whenever we configure OSPF. On router number 1 also, interface fast Ethernet 0/0 IP OSPF network point to point. First, because we are enabling OSPF on Ethernet link, and as you know, Ethernet link is a broadcast. On broadcast link it will perform DR and BDR election. Now on router number 2, if you will check routing table, so IP route, inside the routing table you can see this router is receiving this prefix through OSPF, right? Now rule is enabled, but we will not have problem. So IP BGP, you can see this prefix 192.168.10.0 network is now best as well as valid. So it will advertise it to router number 3. It is not using it. It is not using, router 2 is not using it because it have same route through OSPF. But if OSPF prefix will goes down, it will start using it like this. Okay. But and on router number 3 also we can check BGP table now. So IP BGP, so router 3 have now installed this prefix 192.168.192.168.10.0. This is still valid. This is still valid, no best. So I think synchronization rule is enabled on router number 3 also. Let me check. So running configuration and say section BGP or router BGP, router BGP. Yes, you can see synchronization rule is enabled here. So simply here I am going to disable synchronization rule. Let's say router BGP 65,000. On this router I don't want synchronization rule, so say no synchronization. That's it. And now clear IP BGP star. So IP BGP, and now inside the BGP table just wait for some time. As you know, BGP is slow in convergence, but it will take some time. Next hop in this network is 12.1.1.1 and 12.1.1.1 is reachable. This prefix is not best for now. Yes, now 12 prefix became best here, you can see, and because of that it have this prefix 192.168.10.0 through BGP, right? And this is best as well as valid, so it will install it in the routing table also. So IP dot BGP, fine. So now let me check. Router 1 is receiving 192.168.20.0 network, so IP dot BGP. So it is receiving only 23. Router 1 is not receiving. Why? Because again, as you know, here on router number 2 synchronization rule is enabled. So when router 3 will advertise this prefix to router number 2, it is again receiving route from net prefix from here IBGP neighbor, and synchronization rule is enabled. It is not receiving same prefix from IBGP also, so it will not use that prefix and it will not advertise it to their neighbor, means to router number 1. So on router number 2, between router 2 and router 3 also we need to configure IGP protocol, or it is better if we will disable synchronization rule. See, on router number 2 I don't need to run OSPF, say no router OSPF process 1, because if we are running routing protocol, it is using their CPU utilization, CPU, RAM, memory, right? Router OSPF and 1, say no to this also. we have disabled the OSPF, and this time on router number 2 also I am going to disable synchronization rule, because here we don't need to, we should enable synchronization rule here, and by default it is available. In some other video we will discuss in which scenario this rule should be enabled, right? Otherwise for this scenario this rule should be disabled. So router BGP 65000 and say no synchronization, and now everything is fine. Clear IP BGP star soft in. If you will run clear IP BGP star, it will take lots of time. So clear soft, so IP BGP. Now you can see these two prefixes not best here, but after some time these two prefix will become best, and it is not receiving route from OSPF. Now we have disabled the OSPF routing protocol here. Okay, and so IP BGP, it will take some time. Till then let me pause the video, and now you can see on router number 2 these two prefixes now best. These two prefixes now are now best. So now let me check the R1 routing table. So IP route BGP, so yes, it is receiving this prefix in their routing table. And router 3, so IP route BGP, yes, it is receiving this prefix 192.168.10.0 in their routing table, and now LAN user can communicate with each other. Ping 192.168.20.1. So guys, ping is working, you can see here. And today we discuss two simple troubleshooting ticket in this video. If you have learned something from this video, guys, please hit on like button. If you have not subscribed the channel, please subscribe the channel. We will meet soon in next video. Till then, stay safe. Bye bye. Thanks for watching.